So look at this button here. When I push this button, the LED turns on, and when I release it, it turns off. I push it again, it turns on. I release it, it turns off. So in this video, I will show you how to do this by using digital inputs of the Arduino UNO. Okay, so now let's move to the next part, which is the digital inputs. Here we will use this push button here that I showed in the introduction of this video, which is a simplest form of digital inputs. Push button has been used for many things, as a switch, as a reset switch, as a pulse generator, and many more. Because it is the most simplest, and there are also some example of digital sensors which only give trigger high or trigger low, like the IR sensor. It doesn't give any other values in between 5 and 0. So this is the example of digital sensor. So how to use this, how to connect this to our device, or to our Arduino UNO. So first we look at this connection here. There are two different connections. One with this R connected, this resistance connected to the high, which is 5 volts, and one is connected to the low, which means that this first one here, this resistor here, is being used to pull up these signals to the 5 volts, to the high voltage, or the high states. So which means that when we don't push this button, this will be open circuit, and the data that will come into our Arduino is 5 volts or high. And when we use this one, it is pulled down to the zero, to the ground. We call it as a pull down resistor here, because when we don't push these buttons here, it will goes to the zero, which means that the inputs that comes into the Arduino is 0 voltage. This is why we call here as pull down, and we call here as the pull up resistor. And this connection here that determine how our buttons operate, meaning that if we connect like this button here, when we push, it will give it will short to 0, which means the input that it will give is 0. In other words, if we don't push it, it will give 5, and when we push it, it will become 0, it will become low, which we set this as active low. So this is what we call as active low. When it is active, when we push it, it becomes low, it gives low inputs to our Arduino. And this one here, the figure 2 here, on the other hand, when we push this push button, it will short to the high voltage. Well, again, remember, all currents will flow at the path that does not have any resistor, which means that all currents will flow in here into our Arduino, and what is input in our Arduino is 5 volt or high. In other words, when we push, it becomes high, and this is what we call active high. So these are two different methods of how we going to connect our buttons to our Arduino. And this different connection making the coding is a little bit different, meaning that if you use this technique, you need to trigger low when the push button is pushed. But when you use these configurations here, when you push the buttons, we will code our Arduino to determine the inputs as high. So this means that again, you must make sure which connection you want to choose, because it will determine your coding later on. So now we know how to connect this push button, two different connection of this push button, and now let's look at how to assemble it in our Arduino, in our breadboard. Yeah, so basically there are if you look at this push button figures here, it has 4 terminal at the push button, but you must know how to connect, how to assemble it, because again, if you assemble it incorrectly, you are actually not the button might not function as switch, because it's a short, because this 2 terminal is short and this 2 terminal is short. In other words, if you want it to be able to operate as switch, you must make sure you connect between these two, or between these two, so that the connection will become like that. In other words, when this switch is closed, then it will it can conduct electricity. If you connect between these two here, the blue and red here, so it already short, so whatever you give to this switch here, it will not working, nothing will happen. And that's why you need to know how to, you need to make sure that you connect it correctly. Okay, so that is the basic of how you connect this this push button, and if you look at this this push button figures here, this terminal and this terminal is connected, and this terminal and another terminal behind it is connected, which means that the switch is actually in between these two terminal, which means if you want to connect your circuit, you must make sure you connect in between these two terminal, not like this, not like this, because it's already short. You must make sure you connect, with the blue one here. So which means if we look at this figure here, you must make sure the connection is something like this, not the other way around. So this is how you assemble your circuit on the breadboard. So now let's assemble our circuit. As usual, we directly assemble our circuits. So I just open these circuits here. So try to assemble these circuits. If you look closely, this part here has no changes, it's still the same, the previous, as like in the previous video. Only this part here is changing, which we changed from the potentiometer previously and the temperature sensor into this button, where here again make sure you connect it correctly, and one will be going to the ground and one more will come into the pin 3, and with this resistor of 10k here, since this resistor is connected to the power supply, the 5 volts, means that this is a pull up resistor. When we say this, we will have a pull up resistor, meaning that this is an active low button connections. So again, you can take your time, you can pause this video to assemble this circuit if you have hardware. If you don't have hardware, as usual, open up this Proteus, then construct it. As you can see here, one will go to the port 3 and one will be going to the ground, and as you can see here, we have 10k resistor that connected to 5 volts. So that's it. And since you are using Proteus, we want to see the outputs, or we want to display the outputs in written formats. We can use this virtual terminal again as a simulation for the serial monitor. So you can add this one for serial monitoring. So again, you can pause this video, take your time to assemble this circuit, but again, please make sure that if you use Proteus, if you want to choose this this push button here, So make sure that when you want to choose this push button, when you search for button, so button, there are several buttons here. Choose active, button active. Why? Again, because we want to simulate it, we want to make sure we can push and pull it. So that's why choose this active, and then okay, and then you can draw your circuit. So that's it on how to construct this circuit. So as usual, you can take your time to construct this circuit, and if you are ready, then you can proceed with the next parts of this video. So now you may pause this video. Okay, so now if you are ready to continue, let's open up your Arduino IDE and open a new project. Now we will try to apply all the knowledge that we have covered before. The first one is we can initialize, we can declare our buttons as button, so that we won't confuse later on when we have a lot of buttons. And then that's it first, and then we go to the void setup. In the void setup, as usual, we have the pin mode. We set the pin mode, which is for the pin number 3. So pin number 3, just now if we look at these circuits again, pin number 3 will become input. So when pin number 3 become input, so we can directly write pin 3 input, and then which means this is we declare the input ports. And second things is we want to check, we want to easily troubleshoot or debug our code, whether in order to ensure our connection is correct, or our code is correct. So we use the serial monitor to monitor the output. So we use serial begin like before, with the 9600 baud rate. So this is again for the serial monitor. Okay, so that is from the previous lecture. So now we go on to the next part, which is in the void loop. So in the void loop, we start to tell the button that we have declared previously is basically the value from the digital read. Before this we use digital analog read, but now we use digital read from pin 3. So from pin 3, so means that you need to read the digital value that comes from the port 3. And then if what happens if the button that we read from the digital read is low, we compare the values as low, what will happen is it will do this function. So again, why low? Because we have this active low, the active low with the pull up resistor. So meaning that when it is pushed, this parts here will become will short circuits, and the input that will comes into our port 3 is 0, which means that when it push, it becomes low. And that's why when button is low, then what will happen is we will print the value, and we want to make sure everything goes down, so we use the print line and with the message button press. So this is, we want to make sure that the coding is correct, and the connection is correct. That's it. And then we if the button is high, or we say else if it is not low, we go to the next part, which they will print the other message, which is the print line let's say we just print 0, maybe we just print 0. So print 0, that's it. So 0 is not a statement, so we don't need to put the quotes, and that's it. This is just to check our connection, whether it is connected correctly or not. So now after we've done this, as usual, just check back the coding. So we can click verify, or we can directly upload if you think your coding is correct. So now when we click upload, as usual, it will ask you to save your coding. So save it. So I will save as button. So now it will compile. Okay, so done compiling. So after done compiling, so again, if you want to directly upload, make sure all of this board and ports is correct, and then you can directly go to the serial monitor, because we have already mentioned we want to monitor the value. Now we go to the our circuits here. When we push it, it should say button press, and we release the button, it should say 0. So again, press, button press, release is 0. Simple. That's it. That is the coding, which means that our connection is correct, our circuit is correct, our coding is correct. Now we can proceed. We don't want to short sendiri kan, buat semua benda ni. We just write everything and then suddenly it doesn't function. That's why we try to troubleshoot first using this serial monitor. Okay, so we can continue. Since we now know it is functioning, we want to turn on the LED. So because we want to turn on the LED, what we can do, we can, as usual, we can define where is the LED located, which is now the LED is located at the pin 11, at the pin 11. So pin 11, so that is the pin LED, and as usual, we tell the modes of the pin LED or the pin 11 as output, so that it will give an output currents to that port, and therefore we can have a high luminance of the LED brightness. And after that, we can continue with the, after we get we tell the output LED, then we need to write the output, which is using the digital write. This is all from the previous video, so that's why I go fast here. With the high value when the button is pressed, and when the button is released, digital write with the LED will be low. So that's it. That is the only coding to turn on and to turn off. So in other words, now as usual, we can directly upload. Oh, there is some mistake here. Okay, sorry, missing semicolon. So now we can directly upload again. When we done uploading, as usual, we can open the serial monitor to check, and we can also run our circuit here. So when we push this button here, it should turn on. So see, when I release, it turn off. When I push, it turn on, and the serial monitor also show button press, and when I release, it turn off. So that's it. Simple. So as you can see, it's simple. The coding is simple, and since it is too simple, then we go to one challenging challenge. The first challenge for these parts here. So let's go to the first challenge, which is here. So this is the first challenge for you. Before this, I show in the video where when I push this button here, this LED will turn on, and when I release it, it will turn off. But what I want you to try to do it first is when you push this, it turns on, and even when you release it, it stays on. And the second time you push it, it turns off. So again, first time on, another time it's off. You don't need to hold the buttons to turn on, but you can just click once, it turns on, click again, it turns off. As simple as that. This is your first challenge for this parts here, since it is easy. So hopefully try to do it first. Don't wait for the answer. I will show the answer later in another video. It will not be in this video because I want you to try to do it first. So to help you to solve this problem, I will give you just one hint. I will not give you the answer yet. I will not give you the coding, but just this flowchart here. Try to come up with the coding based on this flowchart here. So what does this flowchart means is when it starts, the LED will turn off. That's why when I show the video, it is off, and then it will check when we push the buttons, it will become low, and make sure that the previous condition is high, meaning that previously it is not pushed yet. So we release it and then we push it, so that's why the previous condition is high because we don't push it, and when we push it, it becomes low. So when there is a change, meaning that we start to push, then it will check whether the LED is on or not. If LED is on, so if you can see here, there is if statement here, so meaning that this have if statement here, and this also have if statement there. If the LED is on, then it will turn off the LED, and if the LED is on, if the LED is off, as you can see here, if it is false, meaning that it is off, then it will turn the LED on, and then it will repeat the loop, meaning that this coding here will be in the void loop. So this is what happens in your void loop programming, void loop coding. We hold the button, we not release it, since the previous cycle, the previous clock cycle is still low. So when previous low, current low, it does nothing. That's why it does not turn off or turn on the LED again and again. So it remains, the LED will remains on, or the LED will remains off if we hold the button. And then when we release the button, which means it becomes high, previously it's low, and then it becomes high, so it does nothing as well. Only when we push, it will turn the LED on or turn the LED off. What this statement does, we need to check the condition every time, because we might hold the button or we might release the button. So the previous condition is still high, now the current condition is also high because we don't click the button. And then when we start click the button, now the current condition is become low, the previous condition is become high. And when we hold the button, or after we click, this low condition will become the previous condition, which means that if we hold the button, now the previous is still low, current condition is still low, it will not do anything. And then it will wait, this condition here will become the previous condition again, and when we release, now the previous condition is low, the current condition is high, it does nothing as well, until and this high condition here will become the previous condition again. And when we start to click again, now the previous condition become high, the current condition become low, now it will turn on the LED again after it turns off. So this is the basic flow chart of this coding here, this challenge 1 here. Try to do it first. Make sure you do it, because later on I will start to give another assessment, the third assessment. I already gave 2 assessments, so the third assessment that I will give later on will be based on this one. So if you don't do this one, you might not be able to do the third assessment. So this is the hint for third assessment as well. So make sure you do it, and don't forget to do it. And again, as usual, any question, just ask me. I will more than happy to help you, and I will try to help you if I can. As usual, if you don't want to ask me in the group, you can ask me privately, or you can just drop the comment down below. And if you have anything to say, just say it down below. If you like this video, as usual, just hit the like button, and don't forget to subscribe. And that's it from me for this time around. And again, my name is Ikhwan, and stay safe, stay curious, and stay joyful. May God bless you. Assalamualaikum.